Hi, so this is the last part of indicator 34 and that will conclude unit 10. And in this, again, learning target is the same because we are still on indicator 34. So I can explain the purpose of a measure of center and what it says about a data set. And that's exactly what we're getting at right now. And I can explain the purpose of a measure of variation and what it says about a data set. I'm going to teach you some extra stuff, which is mean absolute deviation, just in case you happen to come across that. But in this part of indicator 34, you are going to be analyzing measures of central tendency. So you'll be given a data, and then you'll be asked, in order to analyze this data, is mean the best choice? Is median the best choice? Or is mode the best choice? Okay? So there are a couple of things to remember, okay? Think about what does an outlier do to a data set, okay? So let's say, think about what we had talked about, your grades, okay? So let's say you have a 0 in one class and then you had 98, 99, 100, 100. Okay, so think about what that outlier did to your grade. Okay, and that grade was calculated by finding the mean, where you add up all the numbers here, 0 plus 98 plus 99 plus 100 plus 100, and then divide by 5. And it had really pulled down your grade because the outlier was at the lower end of the data set. So here's the thing. Mean is greatly affected by an outlier. Okay, mean is greatly affected by an outlier. So when there is an outlier, mean should not be used because that average is going to become very misleading. Okay, so whenever there's an outlier, okay, when there's an outlier, use median, because look at this now. If I had to find the median of this, okay, and I remove these two, and my median is 99. So is the 0 seriously affecting anything? No, because it's, we're taking the middle number. So the outlier is at the other end and it doesn't matter what the outlier is because we are getting to the middle number. So the median is not affected. So when there's an outlier, use median, okay? Use mean normally, because whenever you're calculating average, normally mean is the best thing to use when there's no outlier. Okay, so when there's no outlier, then at that point, use mean. All right, so let's say you had 92, 94, 97, 100. So there's no outlier here. So that's why mean is a good one to use. Okay, you use mode when you are talking about popular choice. Use mode for popular choice. And this really comes into effect, for example, just think about, especially with clothing color, etc. Think about it. Fall is coming up. Yay, I love fall. And then what are the fall colors? Because at that time, based on popularity, the clothes manufacturers are going to be manufacturing red and orange and browns, yellow. So these kind of colors are going to become your fall colors. You have winter colors. You have spring colors. You have summer colors. So based on that popularity, production goes on. So that's where mode comes in. Okay, so I'm just going to take you to my smartboard because I want to show you how we analyze mean, median, mode. By the way, I can't believe the classroom is set up like this ever in my teaching career because of COVID this year, and so all the desks. Oh well. Okay, so we are going to analyze measures of central tendency here. Okay, and let me go ahead and grab my keyboard while I walk you through this. Okay, so we know that measures of central tendency are mean, median, mode, and these basically refer to the center of anything. All right, center of a data set. Okay, so mean is the average, median is the middle, and mode is the most common, and outlier is a number which is much bigger or smaller than the rest of the numbers. Okay, so this is just a review. Now let's analyze mean really quick. And what can you determine from the mean? If numbers are above or below average. So like let's say if I say on a certain quiz in the classroom, the class average was a 94. So you'll know if you made a 98, you were above average. If you made 88, you were below average. So I'm just giving you, you can calculate as to where you are placing based on the average. And that's how when your pediatrician, etc., they do your growth chart, your height growth, your weight growth, there's a certain average. And then based on that, they can tell, are you really tall based on the average American? Are you shorter than, or same thing with the weight or whatever? They keep up with your growth chart that way because you always have an average amount that you are compared to. Okay. So yes, you can determine if you're above or below the mean. And it is one thing about the mean, I told you, it is drastically affected by the outlier. Okay, so if the outlier is much higher than the rest of the number set, it is going to affect the mean because it is going to pull up the average to a much higher level because it'll be at the higher end of the data set. If it's on the lower end, it's going to drag your mean down because the outlier is at the lower end of the data set. Okay, what you cannot determine from the mean is, if you're doing the average, let's say, when we had done yours and your grade had dropped one letter grade to a B. So at that point, when you are looking at your average, you're not sure that was this because of an outlier or was it that you got all your grades as B's. Okay, so it is hard to determine if the outlier is distorting the data and what the individual scores were because you just have the average. So for each individual test score, you don't have that. You just have the average of all the scores. Okay, again, this is the best choice to describe data unless there is an outlier. Okay, analysis of median. What you can determine from the median, if numbers are above or below the halfway point. Because you have a middle point, so you'll know if the numbers are above that or if they're below that. Okay, this measure is the least affected measurement if new numbers are added to the data. Okay, so if new numbers are added, this is the least affected. All right, what you cannot determine if there were any outliers, like I had just showed you an example. I stuck a 0 there, but 0 was on the outside because you only worried about the middle number. So you can't tell if there was an outlier or not. You also can't tell what the individual scores were. This is usually the best choice to describe data if there is an outlier. Okay. Analysis of mode. Now, mode means most, what you can determine which number or numbers are there the most frequently. Okay. What you cannot determine, where the numbers are in the group of data that is there. Because like, let's say I have 20, 20, 36, 42, 100. So that 20, 20, like which is the mode is absolutely at the lower end of the data set. but that's why when you look at mode, you don't know which part. Is it at the lower end? Is it in the middle? Is it in the higher end? So you can't really tell where the number is in the group of data. Okay. You also can't tell what all the other numbers are. This is the best choice to describe data if you want to select the most popular value or item. Okay, most popular value or item. So, and then range. Range is how far apart are the numbers. So basically, you are looking at how the data is, the spread of the data. That's what it is, how far apart they are. That's what you can determine. What you can't determine is what the numbers are in the data set, because all you're doing is taking the largest number and the smallest number and subtracting. Okay. This is usually the best choice to describe data if you want to know the spread of the data, and that's why you use range. Okay. So let's look at a few examples. And over here it's saying a retail store had total sales of $436, $650, $530, $500, $650, $489, $423 last week. Which measure of data would make the store sales last week appear the most profitable? Explain. So now, guys, when you are showing that it is the most profitable, then you're going to try to use a number which is like right on the top. So that way it looks like your store profits are so awesome. Okay, so in this case, you can see that mode would be the thing to use here, because you have 650 repeated 2 times. But it's also at the higher end. So let's see, can't really call, well, it is also mode, but if I look at 436, 423, 489, 500, 530, those are mostly very much the same. But 650, even though it's the mode, it is an outlier because it is at a much higher end of the data set. Okay, so in this case, in order to make the sales look really good, an outlier would definitely affect. Okay, so in this case, they are using mode, they are using the outlier, and because there is an outlier, what should you use when there's an outlier? Median. Okay, so when there's an outlier, median should be used. However, they are not using that. They are using the mode because it is at the higher end of the data set, and it's going to make it look like the stores have a lot of profit. Okay, let's see in this one. The heights of 5 starting players on the basketball team are 75 inches, 74 inches, 73 inches, 70 inches, 68 inches. Describe whether the mean describes the data well. Explain. Well, if I look from 68 to 75, there is not that much of a difference. Okay, so that is why, because they are clustered together, they are not that far apart, there are no outliers really. So because of that, yes, when there are no outliers, mean is the best thing to use to analyze the data. So yes, it does describe the data well. Okay. Let me just go to, for example, this one. At the end of winter, the 7 sweaters left in stock at Griselda's outlet store were brown, orange, green, orange, brown, orange, orange, orange. Decide which measure of central tendency is appropriate for this data. Explain. So definitely you're looking at mode. Okay, so in this case, you're going to look at, all right, these are left. These are not the ones that are bought. Okay, so whichever one is left the least is better, because that means customers bought it more. Does that make sense? If it's left in the store, that means they were not sold. So that is the color that you don't want to make as much compared to the other colors. Okay, so you would definitely go with mode on this one as to which one is left less. So that is the better one that was sold compared to what is left in the store. Okay, so let's do a problem where I am going to go, I'm going to show you this. And I'm not even going to ask you to calculate mean, median, mode, and all that kind of stuff right now because you can already see what that is. You've already done mean, median, mode. But look at this. You have the sneaker prices. You have $20, $31, $122, $45, $37, $20, $45, $65. So, what would be the best measure? Now we can see there is an outlier. That $122 is an outlier. And because there is an outlier, average would not be a good thing because if I took the average, which is the mean, look, is being calculated, it is showing that the average price of a sneaker would be $48.50. And but there are a lot of them which are much below that, like 20, there are two 20s, there's a 31, there's a 45, there's a 37. So it's actually raising the price. The outlier is raising the mean. So it makes it look much higher, that the cost of the shoes is much higher than what it is. Median doesn't affect, the outlier does not affect the median. And mode is based on popularity, but look, it's at the lower end. So because there is an outlier, median would be the best choice for this answer. Okay. If you look at this one, which measure would best represent the data? So now once again, look, you have 85, 70, 60, 10, 89, 85, 63. That 10 is a serious outlier, is going because it's at the lower end of the data set. It is going to pull your average down. So that is why mean would not be a good choice over here. Median would be a good choice because with an outlier, you use median. Okay, so just wanted to show this to you all so that you understand what I'm talking about. And that's basically what this lesson is about which measure to use and when to use that. And so once again, just a quick review of indicator 34. Indicator 34 is all about mean, calculation of mean, median, mode, range. And then you have analyzing data set, but let me go ahead and teach you something which is a little extra, but hey, you never know when you're going to see this problem. And I want you to understand what mean absolute deviation is. Okay, so let's say I give you a table. And in this table, a scientist is measuring the heights of 5 plants. Okay, so scientist is measuring the heights of 5 plants. And this is the height of the plant. And then we're going to talk about the absolute value of distance to the mean, okay, which is the absolute deviation. Heights in inches. And we're talking about mean absolute deviation. Remember, deviation means how much something deviates or moves away from what it's supposed to do. Okay, over here, that's absolute mean absolute deviation basically is what? Absolute value. And you know what absolute value is? It's the distance of a number from 0 on the number line. But in this case, let me show you what it means. Absolute value of distance to the mean. Okay, that's what mean absolute deviation is. And the mean is what? I told you that the mean is 14. Okay, let me put that here. mean of the plant height is equal to 14 inches. Okay, so here is the mean. So I'm going to write that here also. Mean is 14 inches. All right. So let's say, again, a scientist measures the heights of 5 plants. Their heights in inches are 11, and we have 12 inches, and we have 12 inches, and we have 15 inches, and we have 20 inches. Okay, so when I'm given a question like this, you've done absolute value before, and absolute value is nothing but it is the distance of a number from 0 on the number line. So in this case, when it says absolute, the mean absolute deviation means how far is that number from the mean. We're going to consider the mean as the 0, like what you did in absolute value. So since mean is 14, we are going to see how far is 11 from 14. So if I do 14, if I take 11, I have 12, 13, 14. So it is 11 is 3 spaces away from 14. Does that make sense? So all I'm doing, I'm seeing how far is 11 from 14. So if I do, because that 14 is my mean. So if I do 14 minus 11, my deviation, my absolute value of distance to 14 is 3. Okay, if I say for 12, what is it? It is just 2 spaces away. 12 is only 2 spaces away from 14. Okay, same thing here, and I get 2. That is my distance. Okay, for 15, my distance is only 1, because if I do what is like I can do 14 plus 1, right? Because I have to give that plus 1 for it to be 15. So the distance from 14 to 15 is 1, and the distance of 14 to 20 is 6. This is my distance. All right, so this is 6. So now these are my numbers that are deviating. Deviating means moving away from the mean. That's how far they are from the mean. Okay, so now all I do, I take these numbers and I find the mean of these numbers. So I'm going to take 3 plus 2 plus 2 plus 1 plus 6, and I have 1, 2, 3, 4, 5 of them. So I'm going to divide by 5, and then I get 3 plus 2, 6, 8 and plus 1, and I get 15 when I add this. Sorry, I get 14 when I add this up. And then I go ahead and I divide this by 5. And if I divide 14 by 5, I am going to get 2 times 5 is 10. And I have a decimal, I have 4 remainder, and I get 8/10. So my mean absolute deviation is going to be 2 and 8/10. So I just want to show this to you. If you are given what is the absolute value of distance to the mean, it's how far is that number from the mean. So that's just one more thing I just wanted to show you before we quit this indicator. But that's basically what mean absolute deviation is, if you ever see it or hear it. It's just a little bit of advanced math that I wanted to share with you, okay? So anyway, this concludes our Unit 10. Yes, concludes Unit 10. 33 was all about statistical questions, and then 34 is all about mean, median, mode, range, analyzing, uh, whether mean should be used, median should be used, mode should be used, etc. And then this is something extra that I threw in. So have a wonderful day.